last thing that we added yesterday was a cone. So let's add now, we're going to add a triangular pyramid and a square pyramid. So triangular pyramid is going to be, our volume is going to equal 1/3 times the area of a triangle is 1/2 base times height. We don't want to use height because we also have height of the pyramid. So I'm going to call it altitude. So 1/2 B times A times H. Now, if you want to, you can simplify this one and make it 1/6 B times A times H. I like to keep it separate like this because I can see it's the same as the cone, and like I've got that 1/3 there that I remember. And then that 1/2 is from the area of the base of the triangle. So I like to keep those separate right there, but you could put them together and make it 1/6. So I always have a really hard time drawing these. So I'm going to just draw a triangle, and then I'm going to draw like a line here, and then put a dotted line for like that back side. Now, what I find kind of difficult to label here is that height, as far as like drawing the picture. It's kind of hard. You could call this side right here like your base there, because we're thinking like this right here. I'm going to shade it a little bit here. That's your, that's the bottom of the triangle. So that's the base of that triangle. And then the altitude of that triangle would have to be perpendicular there. So this would be altitude. And then the height of the pyramid is the height like down through the middle of the pyramid, not one of the slanted sides. So I'm going to try to draw that like this. That is your height. Okay. We also need a rectangular pyramid. And this one can also be used if we have a square pyramid, because a square is a type of a rectangle. The only difference is that if you have a square pyramid, so if you have a square pyramid, then it's like your length and your width of your rectangle are going to be the same. So we're going to have volume equals 1/3 length times width times height. Sorry, that keeps going in and out, focusing here. So our drawing for that, gosh, I always have such a hard time drawing these. All right, I'm going to draw a triangle here. Then I'm going to draw like these lines here. This one actually can be solid. We need to connect here and then draw that back side. My drawing's not great because it looks a little slanty, like it's kind of leaning over, but also it keeps focusing things awful. Alright, and in this, we would have a length and a width of the base. I'm going to shade that base a little bit so we can know that's our bottom. We've got a rectangle there on the bottom. And then our height would be down through the middle. Here, that would be our height. Sorry that it keeps, so that won't help. This document camera's terrible. Alright, everybody check your neighbor's note card. See what it looks like. Make sure they got the right formulas. Make sure they have them labeled too. There. Okay, questions? Okay, there are other pyramids. These are the main two that we're going to see here. So let's look at example 5 here. If I am finding the volume of a pyramid, I need to do volume. This is a triangular pyramid because the bottom here is a triangle. And so I need to do 1/3 times 1/2 base times altitude times the height. So, whenever I'm looking at this one, Richard, I have the 1/3 and the 1/2. What would the base of the bottom triangle be? Not 15 there. It's going to be the 13 right here. We would call that our base. And then the height is going to be, or the altitude is going to be the 15 there. Now, if you mix those up, is it really going to matter? Right here, we're multiplying, so it really doesn't matter. And then, Richard, what's the height of the pyramid? Like how high it would sit up off of the ground? 18. That's 18. Okay, so we just have to type that in. Where's my Desmos here? Where to go? Desmos. 1/3 times 1/2 times 13 times 15 times 18. And we're getting 585, so we would get 585 meters cubed for that. Okay, everybody okay here? Okay, the last formula that we need to add is different than any of them. It is a sphere. This is like a ball, right? It's a round solid figure or its surface with every point on its surface equidistant from its center. So every point on the surface of the sphere is the same distance from that center of the sphere. And so we've got the volume of a sphere is just 4/3 pi r cubed. Be careful with this because we use pi r squared so often, right? It's in a cylinder, it's the area of a circle, it's in a cone, Like everything else we got is pi r squared. For a sphere, it's 4/3 pi r cubed. Okay, so make sure you cube this. A lot of kids mess it up because they use a square there when they shouldn't. So let's add this last one to our sheet. So a sphere volume equals 4/3 pi r cubed. Okay, everybody check your neighbors. Make sure they put 4/3 pi r cubed to make sure they don't have it wrong. Because if you start off with the wrong formula, you're going to do badly. Okay, everybody got that one? Okay, so here's an example of a problem that you might have. The radius of the moon is approximately 1,738 kilometers. The radius of the Earth is approximately 6,378 kilometers. Fill in the blank. The volume of the Earth is blank times larger than the volume of the moon. Okay, so just looking at this question, if the moon has a radius of like 1,700-ish and the Earth has a radius of 6,300-ish, I initially sort of think, well, that's probably like what, maybe 4 times bigger, something like that. Seems like it's about 4 times bigger. But we are looking at the radius right here. What is it asking us to compare? The volume, right? The volume of the planet, not the radii of the planets. So, if I want to do this, I need to actually find the volume of each one of these, right? So for the moon, we would have our volume would equal 4/3 times 4/3 pi, squeeze pi in there, 1738 to the 3rd power. And we are going to type that into Desmos. Definitely way too big to do. This here. All right, so we're getting a crazy looking number. What is the calculator doing right there? Okay, it's using these powers. Anybody know what that's called? Julius has got it back there. Scientific notation, right? So it's using scientific notation here. What does this mean when I've got like times 10 to the 10th power? What do I do with that decimal? Move that decimal 10 places to the right. So we're looking at 2. Let's see, oh gosh, I'm not going to move it right there. Small there. 2.19. Here, I'm going to move it right here. 2. 6, 4, 2, 8. See, that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It go all the way to the end, right? 2, 8, 7, 1. Let's just, over here, I'm going to just use scientific notation, and I'm going to round it a little bit. 2.199 times 10 to the 10th. But you would move your decimal 10 places to the right. It would be this number right here for that. If we go back to the Earth, we got 4/3 pi times the radius, which is 6,378 kilometers, and we're going to cube that, and we're going to see what Desmos gives us on this one. Let's change that. 4/3 pi times 6,378 to the third power. This time, we're getting 1.0867 times 10 to the 12th power. Okay, so that means you would take this number and you would move the decimal 10 places. So we'd have 1086781292500, because you're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places, and then you got to go 2 more. That's where I get those extra 2 zeros right there. So these numbers are really big. How am I going to tell how many times bigger the Earth is? So if we're talking how many times bigger, we're talking about multiplying, right? But I'm not going to multiply these two numbers together. That would just give me a huge number. I need to know what number I could multiply by here. I take the moon's volume, I multiply it by some number, it gives me the answer, right? So to figure that out, you would have to divide. You're going to take this number right here and divide it by this number. Oh, gracious. That's not what I meant to do. This number, and we get 49.420. So almost 50 times bigger. And these are like the actual radii of the moon and the Earth. I looked those up when I made this problem. So the Earth is, its volume is like 50 times bigger than the moon. What originally looked like it was maybe just 4 or 5 times bigger is actually a lot, many times bigger, because whenever you start cubing these numbers, they get much larger. Okay. Okay, questions? All right. You have got some word problems next, and I want you guys to try to answer. So, like, what you're going to see in this class, just a straight, here is a box, find the volume for me, is not a Math 3 problem. Right? So, like, this problem that we did back here. Example 1 is not a Math 3 problem. They are probably not going to ask you that on the Math 3 EOC, because this is more like, you know, I mean, I don't know, they might ask a question like this in like 3rd grade or 4th grade, right? As soon as you want them to multiply, they start doing a little bit of this. So they're not going to ask one quite this easy. What you're more likely to see, maybe they'll give you one like example 2. What you're more likely to see are questions like we see here in 7 or 8 and beyond here. So I want you to answer, just start going through these, okay? I want you to read them and answer these questions. Let's see. 9's going to get a little tricky. 9 and 10 are going to be a little tricky. They're backwards. These will be a little tricky. We might need to go through those, but especially 7 and 8. Try those right now. I think you will be able to do those without me just going through them. Plus, some of you are staring. Our volume is going to equal pi times the radius. Joey, what's the radius for candle A? 2. Diameter is 4, but we got to cut it in half. So pi 2 squared times 8. And somebody tell me what you got for that. What was it? Okay. Was there a few more decimals after that? 3, 0, 9, 6. Good enough. Okay. And then candle B, our volume, is going to equal pi times, let's see, Hunter, what's my radius for candle B? Good. So we got 3 squared. And what's the height for that one? 5. And what do we get whenever we 141 point what? Okay. And these are both in cubic inches. Everybody getting the same thing? I'm relying on Zoe back there. I didn't type it in myself. So, in this case, candle B is your answer. Candle B is going to have more wax in it. Okay. All right, let's talk about the guppies in the fish tank. This is something reasonable that you would need to know, because if you put way too many fish in a fish tank, then they're going to die. And if you have a giant fish tank and you only have one fish in it, you're taking care of a really big fish tank, and you could have more, right? So, especially the most extreme is having too many fish in a fish tank, right? They've got to have enough room and food and fresh water to live in. So, you need to find the volume of this. Caden, how do we find the volume for number 8? Good. And so that's going to be 30 times 40 times 30 here. And that is going to give you 36,000, I believe. Now, nobody that whenever I walked around was putting units with this. That is centimeters cubed. That is important in this problem, because they tell us how many cubic centimeters a guppy needs. They do not, right? They tell us how many liters a guppy needs. We do not have 36,000 liters in this tank. I know that we here in America refuse to use the metric system, but this is 30 centimeters, right? We're not talking about a giant fish tank here. So, some of you are getting like 200 guppies or something, right? But 200 guppies fit in a fish tank that is like, this big. No, definitely not. You're going to have a lot of dead fish pretty quickly if you do that. So we need to change this to liters. They gave us the conversion here. This is why the metric system is so much easier than the English standard system. 1 liter is 1,000 cubic centimeters. So what should I do to find the number of liters here? Maze, what do you think? What should we do to find the number of liters? So what do we do to convert it first? Okay, we can do it that way. So we can do that rather than going 2 liters, we could say that 5 liters or times 1,000 is going to give us 5,000 cubic centimeters. So each guppy needs 5,000 cubic centimeters, right? Another way you could do it is you could like divide 36,000 by 1,000 and get 36, and that's the number of liters that you have. But each guppy needs 5,000 cubic centimeters. What do we have to do to figure out how many can fit in this tank? Good. So we'll get 36,000 cubic centimeters divided by 5,000 cubic centimeters, or you may have done 36 liters divided by 5 liters. That'll work also. Either one of those there, whenever you type it in, 36,000 divided by 5,000 is going to give you 7.2. You can't have a 0.2 of guppy, right? So you could have 7 guppies in your fish tank. If you have 8, you'll probably be okay for a while, or maybe all right. I wouldn't put 15 in here, right? Okay, questions on that? All right, let's skip over and look at number 9. We are going to find the diameter to the nearest unit of a cone with an approximate volume of 22 cubic feet and a height of 21. So this particular problem is going to be different than the other problems because it gives us volume and height and asks us for diameter. So we've got to think about what the formula for a cone looks like. Jose, what is the formula for the volume of a cone? Good. Pi r squared times h. And so if we look at what we've got in our problem here, it gives us information, tells us volume is 22. So I'm going to replace volume, the V, with the 22. 1/3 is just a number. Pi is just a number. It does not get replaced with anything. I don't know the radius. Does it tell me the radius anywhere? Nothing. So I'm going to have to just like make that r squared. But it does tell me height is 21 here. Okay. So, and I want the exact number here, not just a guess, because I did see some of you like just trying to sort of guess what that radius would be. I don't love this question. I need to change the numbers a little bit. It is, you can get pretty close just by guessing for this one. But I want the exact number. So 1/3, pi, and 21 are all numbers, right? And everything here is multiplied together. So what I can do is I can go over here and I can type in 1/3 times pi times 21. And I'm getting 21.99114. So I got 22 equals 21.99114 ... r squared. All right. So these three things right here got multiplied together, the 1/3, the pi, and the 21, and that gave me this. So now I've got a pretty easy equation to solve. What would I do, Joey? Okay, we got 22 equals 21.9914 times r squared, and we're trying to solve that for the r squared, so what would we need to do first? Joey? We got to get rid of that 21. What would we do to get rid of it? We can't subtract because it's multiplied by that r squared. So if it's multiplied by that r squared, what would we have to do? Not log, but divide. We've got to divide those. Okay. So we're going to have, we're going to divide by that 21.99. And we're going to keep that number in the calculator. So we got 22 divided by the 21.99114 is equal our r squared. We'll use that calculator to find that. So whenever you do this, copy and paste this. If you're having to use the yellow calculator right now because your internet is insufficient, we've been having some troubles this morning about a handful. I mean, some of them are working and a handful of them are not. So, if you're having to use the yellow calculator, you can just like go up to the line before where you had that number and click on it and it'll pull it down to the next line. And so, 1.0004, what was that? Way 0.02. We'll keep that number in our calculator. Is equal to our r squared. Then we got to get rid of an r squared. Fernando, what are we going to do to get rid of a square? We will square root. So we will square root both sides. And if you're using the yellow calculator for a square root, it's the blue button and the x squared button. There's a square root above that. That's what you're going to hit. But since I don't have that on the computer where you can see it, I'm going to type this in. We got 1.0002. We'll round to that. And that is in feet. Now, we're talking about a radius here, not volume. So it's not feet cubed, it's the number of feet. Okay, so what you're more likely to see on Math 3 stuff is they're not going to ask you just to find the volume of the cone. Or they might, but not most of the time. That's earlier grades, right? They'll give you something like this where you kind of got to work backwards for it. 10 is a similar problem. You have to work backwards on number 10. Try number 10 right now that we've done 9 together. Here. So our formula for a sphere is 4/3 pi r cubed. And so this is our volume. So, oh, I just realized I answered number 9 wrong. What did I do wrong on number 9? What? The denominator, or diameter. It asked for diameter. What did I give? Radius. What should I do to get the actual answer? Multiply it by 2. It should be 2.0004 feet. Oops. Be very careful with that. That's one of the reasons it's really good to write down your work for partial credit, because let's say you did that on the test, you're going to get it wrong. And if you don't write anything down, I'm not going to have anything to give you on it, right? But if you write it down, you've got radius equals 1.0002. I am going to give you most of the credit for that, all right? I'll just take off maybe like half a point for it. There. All right. Back to number 10. 342 goes in for volume. That's here. All right. And then I've got 4/3 times pi times r cubed. 4/3 in pi, that is a number. So I can take 4/3 and multiply it by pi. And I got 4.18879 radius cubed. All right. So, if I'm trying to solve that for my radius, Adela, what should I do first? Good. I'll divide by that 4.18879. Okay, so I'm going to do that over here. 4/3 pi here, so I can just copy and paste. So I'm doing 342 divided by this number right here, and I've got 81.646. That's still r cubed, right? 81.646 is my r cubed. How do I get rid of a cube? Cube root. So I will cube root this, not a square root, but cube root here. And so I need to cube root. It's in your menu. You go to functions. I think it's down at the very bottom. Go to the very bottom. There's a root. And you can type a little 3 out here. Copy. And paste this number here. And we're getting 4.338. So my radius equals 4.338 inches. using the yellow calculator to get to a cube root, you have to hit math and then go down to the fourth thing there. That is how you get to a cube root there. Yeah. Obviously, you can use Desmos. It's a little easier to operate, but our internet is spotty right now. Okay, questions here? All right. We've got a couple more things that we need to look at. We have a rectangular prism that has a length of x, a width of 2x plus 1, and a height of 10. Write an expression that can be used to find the volume of the rectangular prism. So again, this is a Math 3 problem, right? In younger grades, they just ask you to find the volume and they give you the numbers. So we've got a rectangular prism, and we got here our length is x, our width is 2x plus 1, and our height is 10. So for our volume, here it is length times width times height. So if we're writing an expression for the volume, we're just multiplying those things together. So length is x, width is 2x plus 1. Make sure you put some parentheses around that whenever you plug it in. And then our height is 10. They're probably not going to leave it like this. They may, but probably not. We could, if we want, we can do this in any order. So we could put the 10 and the x together here and do 2x plus 1 like that. And then I bet that they will distribute that 10x. So the volume would be 20x squared plus 10x. Okay. Our last one, we've got a cube-shaped bead, has side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. I should say cylindrical hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. Okay, so in this case, I've got a cube here, but in this cube there is a hole that goes down through the middle of this bead, right? So what should I do if I want to find the volume of that bead? What are my, what's the process there? Tell your neighbor, what do you think? Turn to your neighbor, tell them what you think. Fernando can be your neighbor there, Hector. What do you think you got to do? Okay. Anybody's neighbor have a good idea? Okay. What would we divide? I don't think so. Okay, now it does say diameter. We will need to divide because we've got diameter. We will need to divide the diameter by 2 so that the radius is 1, right? So that is part of what we'll have to do. That is a piece of it. So that's not entirely wrong. It's just a piece, though. It's not the only thing. So, our radius right here would just be, gosh, that's ugly, 1. Okay, anybody else's neighbor have a good idea? I like subtraction. Think about making this bead. They probably, I would imagine, if they're making this bead, they probably start with the cube, right? Then what do they probably do with it? They probably drill a hole out of the middle of it, right? So you start with the volume of the whole cube, and then you subtract out the volume of the cylinder, right? So you start with the volume of the cube, and then you take away the part that's the hole. So the cube should be pretty easy for us to do here. Heston, how would we find the volume of that cube on number 12? You can give me the formula, yeah? Yeah, just the side cube. We have another visitor at the door, if you don't mind there, Zoe. It is. He ate his Chick-fil-A in the car this morning. He didn't bring it in like Heston yesterday. But he's missed more class, so I don't know. I think I like Heston's style better. Actually, I like everybody else that was here on time style the best. But, okay, so for that one, Heston, what is our side? What is our side for this one? Good. So our 12 millimeters, we're just going to cube that. And if we do 12 cubed, 12 times 12 times 12, we should get 1728. Okay, so that's like the volume if the cube did not have a hole in the middle, right? Then we need the volume of the cylinder. Caden, how will we find the volume of that cylinder? Very good. So we'll have pi. What's the radius of our cylinder? It's 1. And what's our height of that cylinder? Okay, it goes all the way through the bead, right? So it should be the same height as the bead itself, which has a height of 12, right? So we'll have times 12. So if we do pi times 1 squared times 12, we will get 37.699. So we have this cube that has this volume. We are subtracting out the cylinder. So we just need to do 1728 minus 37.699. I don't know why it does that. So 1728 minus 37.699 is going to give us 1690.301. And that would be millimeters cubed. Okay, questions? All right, what's the internet looking like out there? So, is yours awful? Okay. All right, well, you may get questions like example 1 here. What is the vertical cross section going through the center of the figure shown? So vertical cross section means we're taking that pyramid and we're like karate chopping it straight down the middle, like right there at the point. So if I do that through the center, I got to think about what shape I would be getting, right? What am I going to get? Okay, it's going to be a triangle. You can kind of try to draw it on there. Like if you were to do this, you would cut like down this side, then you'd have that like straight line, and then like back up this side. That's not very helpful, really. That just looks like a line. There, but that would be a triangle. In fact, is it true? Any vertical cross section of a triangle, of a pyramid, is going to give you a triangle, right? Even if the base is different, you should get a triangle for that, I think. Pretty sure that's true. All right, let's look at example 2. Daniel cut the corner off of a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off? So it's not asking us about like the picture we're looking at here. It's asking us about what got cut off of the corner. All right, so is it going to be a cone? I think that one's an easy one to throw out because like that's circular and we don't have any circles here, right? Is it going to be a cube? No, because I definitely have a triangle of sorts right here, right? It's got to involve a triangle. A cube has no triangles. It's not that. Okay? Then C is a triangular prism. D is a triangular pyramid. Okay? What do you guys think? Raise your hand if you think C, triangular prism. Okay? Got several of you. Raise your hand if you think D, triangular pyramid. Okay? Pyramids are correct. It's going to be a pyramid. Because, so, here's our difference. Here, like, if this is a triangular prism, right? This is a triangular pyramid. If I take this, like they said here, get my marker, right? If I take this and I cut off, Joey, get your head up. If I take this and kind of like try to draw those lines right there, if you can picture, let me come around with this, what you'd be cutting off right there, is it like this, or is it going to be pointy on the end like this one, right? It's going to be pointy. So you can see here, like it's going to be a pyramid right there. That kind of helps you see what it would look like there. I think these are hard to picture. Like, there was only about 4 of us that were answering that correctly. And other than like showing you things like this, there's not a lot I can do to like tell you for sure. Like there's some like cube and cone were bad guesses. If you pick those are way off. But between these two, it's a little hard to tell. You know, it's got to involve a triangle. All right. Let's look at 3. We've got a right circular cone. It's represented by the drawing below. Which figure would not be a cross section of a right circular cone? Okay, so let's start with the ones that we know are going to be a cross section pretty easily. What do you think would definitely be a cross section? What do you think, Cannon? See, triangle. What would it look like? How would we cut it? How would we karate chop it? Straight down, right? With straight down karate chop, we'd get a triangle. So it's not this one because they're asking which one's not, right? That is a cross section. What other ones? What do you think, Samara? D. Is D your answer one that you would have? What? We would mark it out? I'm not sure about that. How would we cut it to get a rectangle? It wouldn't. How would we cut it to get a circle like A? How would we karate chop it? Everybody show me your karate chop to get that one. This way, right? You must karate chop horizontal. If we karate chop it horizontally, we'll get a circle. So A is out. I think B's weird. How would we karate chop it to get a... If I cut it at the top like this, still a circle. Still a circle. Oh, hey, Cannon's got it. You got to give it the diagonal karate chop. I do actually have something that'll help us see this one. Because this is conic section. Alright. This conic section's from pre-cal. If you karate chop it perpendicular to the base right here, you get a circle. Right here. If you do the diagonal karate chop this way, you will get an oval for that. So that is. You can also. So the triangle would be a vertical karate chop, like cutting it in half. This one's not set up like that because that's not a conic section. If I karate chop the edge right here, I get this shape, which is called a hyperbola. And if you take pre-calculus, you might learn about that. And if I cut it this way, like give it this diagonal karate chop, this is one you guys know actually. If I can get it off of here. Oh. This one's hateful. Oh no, it needs gracious. Run out of time. There we go. You get this shape. You may know what that shape is. You guys know the name of it. It's a math word. It's a math word. Starts with a P. P. Oh, that's it. Parabola. As a parabola. Like x squared. Whenever you graph x squared, that is a parabola. It's a conic section. This is a karate chop of a cone. Oh, we're at the top of my cone. There. So you can get an oval. That is possible. You cannot get a rectangle from that. So D is the correct answer for that one. All right, let's keep going. All right. So let's picture this. A lot of this is like imagining. You have to have a good imagination. You have to be able to like picture things happening. If I take a rectangle, okay, like this piece of paper, and I rotate it around, like maybe if I could spin it really, really fast, what 3D figure am I getting?
Pyramid.
Cylinder. Definitely not a pyramid. Definitely. All right, so anytime you're rotating, it's going to create circles, right? So like if I take this and I rotate it around like this, then the edge, like the top edge of this is making a circle as it spins. So it would be a cylinder. All right. Okay. Kathleen rotated an, I think this one's hard, rotated an isosceles trapezoid. Isosceles means two sides are the same, but it's a trapezoid. You answer? Okay. So let me draw an isosceles trapezoid for you. It would look like this. It would have like this side would be equal to this side. That would make it isosceles. We're rotating it 360 degrees around its biggest base. So we're taking it, we're spinning it around that way. What are we going to get? It's going to be C, right there. For that. Anytime you're doing rotating, you should end up with circles somewhere. So could you ever get D? No, you could not. What shape would give you B? I need a 2D shape. 2D shape. Triangle. Like if I took a really long, skinny triangle like this, and I rotated it around like that, it'd give me B. D, there's no rotation that you could do. A would have to be like a semicircle or something, or a circle that you could use there for that. All right. One more thing that we've got are nets. So a net is a pattern that you can fold up to make a three-dimensional figure. Lots of things actually like are produced in nets, like if you're making a cardboard box, it gets like cut out of a sheet of flat cardboard, right? So it's a net and then it gets folded up. For this example here, like a cube could look like this. You can picture like folding up those sides. So we need to match each net to its solid. So a cylinder. Okay, net number 1. Got to be 1 because it's the only one that's got circles, right? You could flip those two sides over and roll that around. So that's number 1. Okay? Are you sure?
No.
Net number 30.
I'm not sure.
Okay. What's the difference in a prism and a pyramid? A prism,
Square pyramid is 2.
prism, triangular prism has rectangles on the sides, right? So which one of these is going to be the triangular prism? 3. Right there. And then 2 is your square pyramid. The base is a square, the sides are triangles. Okay? So we'll practice with this some more.